With similarities so far, we've been given shapes with side lengths. The only thing we've been dealing with so far is side lengths.
Now we're going for angles.
Okay? Yep. So, review, looking at these two shapes, how did we determine if these two shapes were similar?
Shape and then you turn them in proportions.
Ratios, right? Yep, you're all getting to the right idea. Proportions. So, if I started with 5, what number or side length on the other shape goes with 5?
10.
10?
5 over 10.
Yep.
Then
With that,
20.
we need to reduce. Okay, we want to get it to simplest form. What can I divide both of them by?
5.
5?
That's 1.
So we get 1 over 2.
Then
Now we got to check the other one. Since I started with 5 up here, I have to start with 10. What side length on the other one goes with 10?
10 over 20. Then you divide
20?
by 10.
Yep, divide by 10. We get 1 over 2. With those, what can we say about those two shapes?
They're similar.
Why?
They're the same.
Because we got the same ratio, that means they were similar. We just put yes. What if they were different?
Then
No.
Then it would be no, right? Good. Now looking at this shape here, we're going to be looking at angles. Okay, with angles, you have to have at least 2 measures that are the same. 2 angle measures that are the same. So between these two triangles, do we have an angle measure that's the same?
Yeah.
90.
Where?
Like,
The 90, right? 90 is the same. Do we have another one?
No.
No. Is there a way we can find another angle in the triangle?
math. Yeah, add them up to like 180 or
Yep. What do all angles in a triangle add up to?
180 degrees.
180 degrees. You got it.
90.
So, if I'm just going to look at this first triangle right here, how am I going to find that other angle?
Add
You
them
add
together
90
minus
plus
180.
61.
Yep.
That gives
Take
you
90 plus 61
151.
to get 151.
Just minus that from 180. That
Right.
gives you 29.
Now take 180 minus 151 to get 29.
Oh, hey.
That
Adds up.
29 gives us this angle right here.
That works.
Now, do we have another angle that matches?
Yeah.
29 matches, right? How many angles did I say we need to have to prove they're similar?
2.
We have 2 of the same, so this one is automatically yes. Why can we assume that they're similar with only 2 angles?
Because they're the same. Same number.
So what do you know about the third one?
It's going to be the same.
It's going to be the same no matter what, right? So you only have to prove that 2 of them are the same. You don't have to prove all 3.
So we're not even really doing proportions for those ones then.
Nope, no proportions with these. No proportions with these. Okay. Any questions on that example right there? Okay. Looking at this example up here. First off, do you see 2 triangles?
Yeah.
Yeah.
We have this main one. And then we have the little one on the inside. Okay? What they've done down below is they split it up into 2 different triangles.
Yeah.
Okay? Between those 2 triangles, do we have anything that's the same?
Yeah.
48.
48. Good.
But we're missing.
Do we have anything else that's the same?
No.
No.
Other than the shape.
You can
but-
assume.
The shape, don't assume. You can't assume until you got 2. Looking at them together, do they have anything shared?
Besides.
They have some sides that are shared. Do they have any angles that are shared?
Yeah. The 48 degrees.
Ansley's nodding her head.
The middle line.
R, right? R up here is in both triangles. It has that shared angle. Because if you look down here, R is on both diagrams. So remember when we were doing side angle, side last semester? We could assume some things. You can assume that shared angles are the same.
Yeah.
Okay? So we have R and we have 48. Can we assume these are similar?
Yeah.
Yes. Why yes?
You got 2.
We got 2. Yep. Once you have 2, you can say they're similar. What if we only proved that one angle was the same?
No.
It would be no. Yep. Good. Go ahead and get these 2 examples on your own. Try 1 and 2. Say if they're similar or not. Remember, you have to show that you have 2 angles that are the same. Show them by circling them. So, looking at number 1, we want to see if we have any right off the bat that are the same. Do we have any that match? Right. We have 80 Do we have any other ones?
No.
No.
You gotta-
But can we just automatically say no?
No.
No, we gotta check.
Add 'em up.
We gotta see if we can find this other angle.
80
You
plus
can do
65.
either triangle. I'm just gonna pick this one. Okay, if you did the other triangle, that's totally okay. All right. So how do I find the missing angle?
80 plus 65.
Yep, add them together. 80 plus 65 to get
145.
145. Once I have 145, what do I do?
Minus it from 180. That gives you 35.
Take 180 minus 145 to get 35.
And thus you have two angles.
So now we have 35 and 35. Are these triangles similar?
Yeah.
Yes. Why can we say yes?
Two angles.
Because we found two angles. Yep. On 2, do we have any right off the bat that are the same?
G and 27.
27 we see, and then what else can we assume is the same?
G.
G, because it is a shared angle. Okay, so we have 2, so our answer is
Yeah.
yes. Alright. What do you notice about 3 and 4 on the back of your notes? Start with angles first. Looking at number 4, do we have 2 angles that are the same?
Yes.
Okay, little review. What do these red marks mean? They're the same. So congruent, I like that word. So we have one pair of congruent angles, and then we have another pair of congruent angles.
You got two.
Okay, so by the angles, is this similar?
Yeah.
Yes, but we have to find the missing side. Remember how to find the missing side?
Sort of. It's like
What do we have to set up to find the missing side?
here. It's like a
Starts
plus
with a
b
P.
squared. Pythagorean theorem.
Not Pythagorean theorem.
Stupid and hard.
We gotta set up our own ratios and proportions. Yep. So if I start with 5, what side length on the other triangle goes with 5? 3. Yep.
50
So review.
y.
5 on this triangle matches up with 3 on this triangle. Since I started with 5 on this triangle, I have to start on the same triangle at 15. So I have 15 on the other one. What side does 15 match over here?
Y.
Y. Good. What sign needs to go in the middle of those two ratios? Equal, because we know if these triangles are similar, they need to be equal to each other. Okay? So we set up our own proportion. How do we solve?
3 times 5 is
What method are we using?
cross multiplication.
Yep. So we have 5 times y,
5y equals 45.
5y, and then 3 times 15 is 45.
Divide by 5. That's
Last step we do is divide by 5. So we get y equals
9.
9.
And that means they're the same. So
Yep, and that's it. So on these, we're just finding the missing sides. Okay? Number 4, we'll go ahead and do this one together. Start with angles. Do we have a matching set of angles?
Yes.
C.
Right. D and C, because of their marks. Do we have another pair? Where? B, right? Those vertical angles. Remember that vocab?
Yeah.
Vertical angles, shared angles. Okay, good. So angles, we know they're similar. So now how do we find the missing side?
6 over z.
So if I'm starting with 6 over here, over
z.
z,
12 over 6.
and since we started with 6 over here, we have to start with 12, and then go over 6.
6 times 6
Okay.
is 36.
Yep.
Equal
6 times 6, we get 36,
12 z.
and then z times 12,
36 divided by 12.
yep, divide by 12. We get z equals
3.
3. So on those, you're proving they're similar by the angles and then finding the missing side. Okay? Any questions over similarity? We just added another property.
How many questions are in that?
All right.